Hi, my name is John Helfen. I am an education solution specialist with Autodesk, and today I wanted to provide an overview of the finite element analysis environment, or the FEA environment, and also the dynamic simulation environment in Inventor. And really I want to look at how those two environments work together. You can actually use the dynamic simulation environment to generate real-world loads that can be applied to a part in a stress analysis. So for this presentation, I actually decided to create a trebuchet, which is essentially a catapult of sorts. Historically, it's been made of wood, but I figured why not modernize it for Inventor, and I went ahead and created the parts in Inventor as milled aluminum components, and I've assembled them so that in the assembly environment, if I click and drag, you can actually see that they move as you might expect, rotating around the shaft in the center. So to start out, what I wanted to do was first do an FEA analysis on this arm here in the center, and then I'm going to go through and set up a simulation where we'll actually do a simulation of launching the projectile using the trebuchet, and then we'll collect the forces that are generated during that simulation and rerun that analysis on that same part at the end. So to get started, I'm going to go ahead and right click and open this component in its own window so we can focus on it, and I will jump into the stress analysis environment. You can get to it from the environments tab on the ribbon bar and the stress analysis icon. So when you jump into the stress analysis environment, it actually changes just in a similar fashion to moving into sketch or assembly mode. It automatically adjusts all the tools that you would need to do an FEA simulation. So to get started, we can create a simulation using the icon on the left, and that brings up this new simulation dialog. Now we're going to go ahead and create a static analysis, single point analysis. Inventor also has the ability to do a parametric dimension analysis, where you could change or set a range of sizes for specific features in the model to run multiple simulations at once to find out which one is the least amount of weight with the highest safety factor, for example. But in this case, we're going to start out with just a basic single point analysis. So I'm going to go ahead and hit OK, and the browser actually pre-populates or creates, essentially areas in the browser where we're going to collect information as we set up this simulation. So the browser from top to bottom works the same as the ribbon bar from left to right, and it's generally in the same. You don't have to follow this workflow, but it generally is a nice workflow working from left to right to get to the simulation. We're not doing a parametric table, so we're going to go ahead and skip that. But you do have the ability to assign materials. It will bring over the material from the assembly or the part if you've already assigned it. If you wanted to, say we didn't want to use aluminum, we wanted to override just for the simulation, we wanted to override it with cast iron or steel, we could do that here. But we're going to go ahead and leave the defaults for now. Next are constraints, and we're just going to use a single fixed constraint to start out. We're going to fix this center point, which is where the shaft would rotate around the arm would rotate around the shaft. I'm going to go ahead and apply that. When you do that, you can actually see the browser has been populated with a new fixed constraint. So if we wanted to, we could come back and highlight this or hover over it and get it feedback as to where it is in the model. In this situation, this is not hugely important, but as things get more complex, it's useful to be able to come find something in the browser and see it where it is on the actual model itself. So next we're going to go ahead and create some forces to apply to the model. In this case, we're going to use the hole on each end as the place to apply the force. And here, when I selected it, it puts the force in at a strange angle. If I had straight lines in this assembly, or in this part, I could actually just select a straight line to align the vector, the force vector. In this case, I'm going to go ahead and use vector components, and this is just a way to manually place forces in a specific direction. So we're going to put it in this Z direction here, and I'm going to go ahead and apply that, and you can see that the force has been aligned to the Z in this part. I'm going to go ahead and do the same thing at the other end. It keeps the same settings from the last one, 150 pounds in the Z direction. I'm going to apply that. And now we actually have everything we need to actually run the analysis. But before we do that, I wanted to show one more. It's in the one more item. It's in the prepare section, and that's mesh view. I'm going to go ahead and click that and let it calculate the mesh. So what it's doing is actually generating the mesh that will be used to calculate all the stresses. And once that's, oh, here we go. Now you can actually see the mesh that's going to be used to run the FEA analysis. Now the reason I bring it up is a couple of reasons. First, if you run the mesh first, you can make sure that everything looks alright, and it speeds up the actual simulation time because it doesn't have to calculate the mesh at the same time. But really, if you zoom in on this fillet corner, you can see it's a little bit choppy. You can set in the stress analysis settings up here on the toolbar, you can actually set the size of the elements, and that is meaning the triangles that are used to generate the mesh. You can change that for the overall model, or you can actually use what's called local mesh control, which will give you the ability to tighten up the mesh in just a small region. And that's useful in that you don't actually have to shrink the number of elements across all these flat faces, because that really isn't useful. But in the corners, the smaller the mesh, the more numbers of points of calculation will take place. So you'll actually get a much more accurate reading. And in the corners or tight spots, that's, can be useful. So let me go ahead and put in a smaller number here, and pick this corner face. And I'll go ahead and hit OK. And you can see as soon as I hit OK, it tells me that my mesh is out of date here in the browser with the red lightning bolt. I'm going to right click and hit Update Mesh. And it's going to recalculate that, but it's going to take into account the change we made just for that face. And when it completes, you'll actually see this is going to look much smoother. Instead of these long triangles, you get more, a larger number of triangles, and essentially it is generating a larger number of points of calculation, so you'll get a more accurate result. Now keep in mind, the smaller the elements, the more number of points are going to be calculated, and the more powerful or more time your computer will need to be, or the longer it will actually take to run those calculations. So you'll want to keep that in mind when you're adjusting these settings. But I'm going to go ahead and zoom back out, and I'm going to actually turn off the mesh now, and we'll go ahead and run this simulation.